This video will teach you how to find logarithms. A logarithm is an exponent. The definition of a log is y equals log base a of x, where a to the y power equals x. A is the base of the logarithm, and a remains the base of the power. X must be a number greater than 0 or positive, and the base a is a positive constant other than 1. So in other words, a logarithm with the base of a of x means a to what power equals x. This is the form that we'll use when we work problems. Now let's look at some examples. The directions say find the following: log base 2 of 8. Now the base is 2, so we think 2 to what power would give us 8? Well, 2 times 2 is 4, times 2 is 8. So that would be 2 to the third power equal to 8. So the power that made that true would be 3. So this logarithm, log base 2 of 8, would equal 3. The next example is find the log with the base of 4 of 16. Using our definition, the base of 4 to what power would give us 16? Well, we should know that 4 times 4 is 16. So the power would be 4 squared. So this logarithm equals 2. Another example, log base 5 of 5 to the third. We need to figure out what this equals. So the base is 5. By our definition, that means 5 to what power equals 5 to the third. Now notice on this problem that our bases are equal. And the base exponent property says if the bases are equal, then the exponents must be equal. So for the left side to equal the right side, our question mark must have the same power of 3. So this means that the log base 5 of 5 cubed equals 3. For the next problem, we need to find log base 3 of 1 over 9. By definition, this means 3 to what power equals 1/9. Now, when we think of powers, we usually think of the numbers getting bigger, but in this case, 3 changes to a fraction which is smaller. So we know that 3 squared is 9. So in order to get the reciprocal of 9, we need to think about the opposite power of 2, which would be negative 2, would give us 1/9. The rule works like this: a to the negative n power equals 1 over a to the positive n. So the 3 to the negative second equals 1 over 3 squared, which is 1 over 9. So our answer is negative 2, and log base 3 of 1/9 will equal negative 2. Now there are two types of common logs. The first type of common logarithm is a log with a base of 10. Any log with a base of 10 will not have the base written. It is assumed that if we write the word log, that the base is automatically 10. For example, suppose that we have a problem that we need to find log of 1,000. Now we would know the base is 10 because there's not a base written for the problem. So this means 10 to what power is 1,000? Well, 1,000 has 3 zeros, so 10 to the third power equals 1,000. Our answer would be 3. Looking at another problem, find the log of 0.01. Again, the base is not written, so we assume it to be 10. 10 to what power is 0.01? Well, we need to think about negative exponents to make the number smaller. If we look at 10 to the negative first power, that's the same thing as 1 divided by 10, which would equal 0.1. 10 to the negative second power is the same as 1 over 10 squared, or 1 over 100, and that is 0.01. That's the number we're looking for, so the power that would make that happen is -2. So log of 0.01 equals -2. One more problem. Find the log of the cube root of 10. Again, we know that the base is 10, so 10 to what power is equal to the cube root of 10? If we change our cube root to a power, then we know the answer. This is 10 to the first, so the power here would be 1/3. It's always this power over the root. So in order for these to be equal, notice we have the same basis. Therefore, the powers must be the same. So the question mark must be the same power of 1/3. So this logarithm with a cube root of 10 will equal 1/3. Now the second type of common log has base e. E is Euler's number. So if I write log base e of x, this log is a special log abbreviated by ln, and ln is called natural log. Natural log always has a base of e. So for our problems, suppose we need to find the ln of e to the 1/3 power. Now notice that the base isn't written with an ln, but we assume it to be e. So our definition is e to what power equals e to the 1/3. Again, we have the same basis, so we have to have equal powers. So our answer would be 1/3. So ln of e to the 1/3 equals 1/3. Another problem is ln of the square root of e. Again, we have a base of e, so we know e to what power equals the square root of e. A square root has an imaginary 2 here, and e would have a first power. So changing this to an exponent, we would get 1/2. Again, the bases are the same, so the exponents must be equal. So the power we're looking for is 1/2. So two common types of logarithms are logarithms with a base of 10 and a natural log with the base of e.